All right, guys, Unit 10 is on logarithms. Logarithms sound really scary. I'm using Miss Marzek's notepad, so she does a really good job, so some of the stuff in here is going to be pretty cool. Well, maybe not cool, but it's cool to me, so. All right, Unit 10, let's see. So, day one is called compositions and inverses. So I think you guys did inverses in Algebra 1, but let's, here, compositions. Here's a composition, G of f of x, or G of f of x. Probably could put a parentheses around there. So you have to work backwards. So what we're gonna do when we see this is we gotta do f of 3. So if you plug 3 into f, that's 6 minus 7 is -1. So now it's g of -1. So -1 squared is 1, plus 4 is 5. So if we do f of g of 3, so g of 3 is 9, so plug it in g, 10, 11, 12, 13. Now I gotta plug 13 into f. So 2 times 13 is 26, minus 7 is 19. So they're not the same. So now let's plug it in with x. So f of g of x. So f of g of x is x squared plus 4. So now I got to plug x squared plus 4 into f. So 2 x squared plus 4 minus 7. So 2x squared plus 8 minus 7, 2x squared plus 1. That's f of g of x equal. So it's a brand new function. Or you could write the way it's written here. So now let's go in reverse. So f of x is 2x minus 7. Now I have to plug this into g, but I'm plugging it into the input value. So 2x minus 7 squared plus 4. That's 4x squared minus 28x plus 49. Foil that out, plus 4. So 4x squared minus 28x. So 49 and 4 is 53. And I'm going to plug f into itself. So f of x is 2x minus 7. So 2x minus 7 it's always going into the input value. So 2x minus 7, minus 7. So 4x minus 14 minus 7, so 4x minus 28. Okay, inverse of a function. So with an inverse, you switch x and y, which means you switch the domain and the range. It's inverted. So to find an inverse, you switch x and y and solve for y. So this is the original function, all right? And this function is a line, start at -5, go up 3 over 1, up 3 over 1, just like this. So the domain is all reals, the range is all reals, and I gotta find the inverse. So what I do is I switch x and y, and I have to solve for y. So add 5, divide both sides by 3, but I'm going to write y over here. It's x plus 5 over 3. That's the inverse function. Well, so look at, if f of x is 3x minus 5, then f inverse x. You use -1. It's not the reciprocal, it's the inverse when it's written like this. Over 3. So the domain of the inverse is the range of the function. The range of the inverse is the domain of the function. It's the same, but you have to flip-flop them. All right, so here's some finite function, only has 3 points. This has an infinite amount of points. So the domain are all the x's, 0, 2, 3. The range are all the y's, 1, 2, 4. And the inverse, we have to just reverse them. 1, 0, 2, 2, 4, 3. So the domain is 1, 2, 4. Range is 0, 2, 3. So they flip-flopped. So remember, the x's are the domain in that case. All right, so there's no variable on the denominator, and there's no square roots anywhere. So these are still all reals, because it's really 1/5 x minus 3/5. It's a linear function, so the domain and range are all reals. So to find the inverse, switch x and y and solve for y. So multiply both sides by 5 and then add 3. And these are still all reals. So H inverse is 5x plus 3. So because we switched the x's and the y's, the inverse function, well, a function and its inverse are reflected over y equals x. So I'm going to sketch 3x minus 5, and I'm going to do that, and this graph is so small, so 3x minus 5. So 1, 2, 3, 4, 5, and then I'm going to go up 3 over 1, up 3, 1, up 3 over 1, 3 over 1. And I need a ruler. Let me go more. Up 2, 3. And we got to sketch the inverse. So the line y equals x is this. It's in all the diagonals. Can't see this. So here's f of x. All right, now I gotta sketch the inverse. So what you could do is you could, 1, 2, 3, 4, 5. So y is -5 becomes x is -5. 1, 2, 3, 4, 5. And this point's gonna stay the same. So I could just connect those. So this is the inverse. And notice, this is a reflection over the blue line. See, if I were to, so you fold that blue line up, the green and the red would almost match up with it. They're an equal distance away. And the domain and the range of, well, I'm not sure which one they want, but they're all reals for both of them. So to find the inverse algebraically, switch x and y, solve for y, which we already did. Okay, so let's sketch this one. All right, so it's going to be x squared, well, here, 9 minus x squared, second table, so at -3, I get 0, -2, I get 5, negative 1, I get 8, 6, 7, 8, negative 9, and then symmetry. Now, I have to sketch the inverse. So I got to draw on the line y equals x. And now I have to just reflect everything over the line y equals x. And this is going to get a little ugly. So the parabola is going to look something like this. Okay, so the tip is at 9. So if y is 9, that means x is 9. So that's going to be the tip. It's going to go like this. These points are always the same. So when 1, 2, 3, when x is 3, that means y is 3. 1, 2, 3. When x is negative 3, that means y is negative 3. 1, 2, 3. And I think I have enough to kind of sketch this one. Well, all right. Maybe I should get one more point. Let's get one more point. This is the point 2. 1, 2, 1, 2, 3, 4, 5. This is the point 2, 5. So on the inverse, it's got to be 5, 2. So 1, 2, 3, 4, 5, 1, 2. See how that works? You just flip everything. So we got to draw a parabola. Yeah, something like that. But if I were to pick it up, they would eventually match up with each other, folding over that line. All right, the domain of the function is all reals. The function is red. The domain is all reals. The range of the function is negative infinity until 9. So the domain of the inverse is the range of the function, which is true. The domain is negative infinity to 9. The range of the inverse is the domain of the function. The range is all reals because this is going to go like that. So is the inverse of function, is the green a function? It's not, because the green fails its own vertical line test. So I really shouldn't write F inverse because that's implying that it's a function. I probably should have write, the domain of the inverse relation. Every graph is a relation. But if it's a function, then you just say it's a function. So you just replace the word relation. But, find the inverse algebraically. So x equals 9 minus y squared. So subtract 9. All right, so let's add y squared over here. And then we're going to get 9 minus x. And then I take the square root plus or minus radical 9 minus x. All right, that is not a function because you can't have a plus and minus with that. But notice, it's a square root function. Here's the positive one. Then I reflect it. Here's the other one. So sketch the graph 2x cubed plus 1. Just going to get some points here. Probably not going to go to 53, so... Well, all right, negative 1, I get negative 1. At 0, I get 1. And at 1, I get 3. Let's just see what this graph looks like. It's going to be like this. All right, so let's do our best just to draw that. So let's sketch the inverse. All right, so we got to draw on the line y equals x. Well, actually, before I do that, so I had -1, -1, 0, 1, and 1, 3. So on the inverse, it's going to be no, the inverse was in green. -1, -1, and then 1, 0, 3, 1. So let me draw those points in. So -1, -1, 1, 0, 2, 3, 3, 1. This way I at least know where the points are. And then I'm going to sketch in y equals x. Let me just go from corner to corner. So notice it's going to the line, to the line. So I got to do the same thing here. So well, here. This. That's hard to draw. The regions won't make you actually draw one. That was kind of confusing, but that's what it would look like. Is it an inverse function? Yes, because it passes the vertical line test. All reals for both of them. So if you go back here, if you notice the red one fails the horizontal line test. If a graph fails its horizontal line test, that means the inverse is going to fail its vertical line test. Get it? So the red one is a function because it passes the vertical line test. The red one does not have an inverse function because it fails the horizontal line test. And the green one fails its vertical line test but passes its horizontal line test. So they're all related. Okay, that's it.